We're going to work on today is going to be your foldables. So you have a total of 5 foldables over all of the concepts that we've gone over this year. And when I get back, or when we get back after Thanksgiving break, we're going to take these out, glue them onto colored paper, and then put them into your binders so that you'll always be able to access them and not lose them. In the meantime, though, I need you to not lose these. You do not need scissors. We'll use the scissors after we get back from Thanksgiving break. So all I need you to do right now is just go through and fill these in. So the first foldable that I'm working on right now is the multiplying fractions, dividing fractions, so all of your fractions one. So go ahead and get to that. Pause this video if you need to. Okay, so when you open it up to the inside, the first thing that it talks about is multiplying fractions. Now, the big thing to remember when you multiply fractions is if you have if you have mixed numbers, then what you need to do is you need to go through and you need to turn those into impropers first. So that's what this is talking about right now, is turning those mixed numbers into impropers. But basically, when you multiply fractions, it's really easy. You just do tops times tops and bottoms times bottoms. If that little smudge bothers you right there, that is a multiplication symbol, so you can rewrite that. So you just do tops times tops and bottoms times bottoms. 3 times 5 is 15, and 7 times 8 is 56. Sometimes you will have to simplify, but that's just something that we should already know how to do. Then the next slide is talking about dividing fractions, and when you divide fractions, you also need to make sure that you turn mixed numbers into improper fractions. When we divide fractions, we keep, change, and flip. But the big thing to remember is that is also known as multiplying by the reciprocal, because I'm pretty sure when you make it to next year, they're going to ask you to say multiplying by the reciprocal. So this right here would keep 3 over 7, change the division to multiplication, and flip 5 over 8 to be 8 over 5. And then after that, you do exactly what we did with multiplication, which is tops times tops, bottoms times bottoms. So we do 3 times 8, and 7 times 5, and 3 times 8 is 24, and 7 times 5 is 35. The next thing we have is adding and subtracting fractions. When we add and subtract fractions, the big thing to remember is that we need the same denominator. So let's take, for example, 6 and 9. What I'm going to do, because these are my two denominators and they have to be the same before I can add them, I'm going to go through and I'm going to list my multiples of 6 and 9. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, times 4 is 24, times 5 is 30. 9 is 9 times 1 is 9, 9 times 2 is 18, and I could keep going, but I see an 18 right here and an 18 right here. And to get 6 to 18, we said we had to multiply times 3. And to get 9 to 18, we have to multiply times 2. So I'm going to multiply my 6 up here times 3. And if I multiply that times 3, I also have to multiply 5 times 3. And I'm going to multiply 9 right here times 2. So I have to multiply the top also by 2. 3 times 5 is 15. 3 times 6 is 18. And then you have 1 times 2, which is 2, and 9 times 2, which is 18. Then we just add the numerators and keep the denominators the same. So 15 plus 2 is 17, and then you keep the 18. The next section is how to turn a improper fraction into, how to turn a mixed number into an improper fraction. We do the Texas method. So we start down here at the bottom of the arrow, and we start by doing 7 times 1. And then after that, we finish by adding the 5. So 7 times 1 is 7, plus 5 is 12. So that's it as an improper fraction. If you were to take an improper fraction and go to a mixed number, you just divide the numerator by the denominator. So the numerator is 14, the denominator is 3. 3 does not go into 1, but it does go into 14 4 times. And then that gives you 2. This number up top is your whole number. This number at the bottom is your numerator. And then this number right here is your denominator. So that would give you 4 and 2/3. If you were to turn a fraction, whoa, I'm so sorry. If you were to turn a fraction into a decimal, you keep the whole number. So we're going to keep that whole number big, which is 2. And then we add a little decimal. And then to turn the fraction into a decimal, I do 3 divided by 4. 4 doesn't go into 3, so I have to add a decimal and a 0. 4 goes into 30 7 times. That gives us 28. Subtract, and that gives us 2. Then we add another 0, drop it down, and 4 goes into 25 times. So our whole number is still the 2. And then when we divided the fraction, we got 0.75. So if you ever need to turn a fraction into a decimal, that's how you do it. Okay, if you need to go back and rewatch any of this, you can, but here's the fraction one real quick, or the multiplying fractions one real quick. Here's the dividing fractions one real quick. Here is your adding. Here is, right here, is your turning your mixed numbers into improper fractions. This is turning an improper fraction into a mixed number. I should probably circle that right there for you guys. There you go. This right here is turning a fraction into a decimal. Okay, I'm going to move on. The next thing we're going to talk about is decimals. So, we're going to talk about adding and subtracting first. When you add or subtract, you have to line up decimals. Only with addition and subtraction. So if you look over here, we have the example of 1.5 plus 3.75. First thing I did was lined up my decimals. Now 1.5, the 1 goes before the decimal, the 5 goes after. In 3.75, the 3 goes before the decimal, the 785 goes after. I have 2 little blanks right there above the 85, so I have to add a 0 and a 0. When you add them, that gives you 5.285. The big thing to remember is just that you have to line up your decimals. Then you have multiplying decimals. So the number with the more digits goes on top. So you do 3.785 on top. And then you put the number with the less digits on the bottom. We start by multiplying 5 times all of these numbers. So 5 times 5 is 25. So I write down a 5, carry my 2. 5 times 8 is 40, plus 2 is 42. So I write down a 2, carry my 4. 5 times 7 is 35, plus 4 is 39. So I write down a 9, carry my 3. 5 times 3 is 15, plus 3 is 18. I'm on my second row now, so I add a 0. 1 times 5. Now we go through our 1s. So we finished here, and now we go through with our 1s. So you have 1 times 5, 1 times 8, 1 times 7, and 1 times 3. So 1 times 5 is 5, 1 times 8 is 8, 1 times 7 is 7, and 1 times 3 is 3. After that, we add. Then, this is the big thing to remember with multiplying decimals, is you count up how many decimals you have in the first row. So in the first row, we have 1, 2, 3. In the second row, we have 1. So 3 plus 1 is 4. So our answer will have 4 decimal places. The next one is dividing decimals. So there's 2 different types of ways that we divide decimals. The first one over here is if you just have a whole number on the outside. So the order in which you divide is, the way to remember it is, does McDonald's sell burgers? So you start by dividing, then you multiply, then you subtract, and then you bring down, and then you go back up to the top until you run out of numbers. Now, I don't know my 22's chart, so what I'm going to do is I'm just going to add 22 over and over and over again. So this right here is 22 times 1. I add, and that gives me 44, which is 22 times 2. I add, and that gives me 66, which is 22 times 3, and then so on and so forth. I'm going to do this silently now. Okay. So you should have something that looks like this. If you need to pause for a second, you can. What I'm going to do now is I'm just going to box these so that I can quickly find them. And I only go to 9 because you can only put numbers 1 through 9 up at the top when you're doing long division. Okay, so we start by looking if 22 goes into 3. Now, if I have 22 friends and I'm trying to break up 3 candy bars to give to 22 friends, I can't do that. 22 doesn't go into 3 because it's bigger than it. Then I have 22 going into 36. Well, I come over here and I look at my facts. 22 times 2 is 44, and that's too big. So I have to go with 22 times 1. So I put a 1 up here. And 1 times 22 is 22. Subtract, and that gives us 14. And then after that, I drop down my 3. Now I'm trying to see how many times 22 is going to go into 143. So I come over here and I look at my facts. 154 is too big. So I go with 22 times 6, which gives me 132. So I put a 6 above this number right here. And 6 times 22 was 132. So I subtract, and that gives me 11. Now I'm out of numbers. But with decimals, I don't just stop when I run out of numbers. So what I'm going to have to do is I add a 0. If it doesn't already have a decimal, you have to add a decimal and a 0. And then I drop that 0 down. And then I divide, and I see how many times 22 goes into 110. If we look over here, we see that 22 goes into 110 5 times. So I divided, now I multiply, and 5 times 22 is 110. Subtract, that gives me 0. So we know that we finished because we have no numbers left over here up at the top, and we got 0 down here at the bottom, so we're completely done. Now I just bring up my decimal, and that gives me 1.65. Right here, decimal goes straight up. Now this is the one that I always see the most struggle bus with, and it is because there is a decimal on the outside. When we have a decimal on the outside, and only when we have a decimal on the outside, we move it. So I have to move this decimal over 1 time to turn that into a whole number of 16. Well, since I moved that decimal over once, I have to move this decimal over only once. And so that decimal now goes in between the 6 and the 8. So that gives me 76.8. Now I can divide this. I'm going to go through and list my 16s facts. So this is times 1, this is times 2. Actually, I'm going to fully write that out so it makes a little bit more sense. 16 times 1, 16 times 2, times 3, times 4, times 5. And then I just go through and I box these. Okay, then I come back over here and I'm doing 16 into 76.8. Now 16 doesn't go into 7, it's too big. So now we see how many times 16 goes into 76. I look over here, 16 times 5 is 80. That's a little bit too big because it's bigger than 76. So I'm going to go with 16 times 4, which is 64. Subtract, and that gives me 12. And then I drop down my 8, and I see how many times 16 goes into 128, which is 8 times. 16 times 8 is 128. And I'm out of numbers because that gives me 0. And there's no numbers up here. So my final answer, and remember I just bring my decimal straight up, is 4.8. And right here at the bottom, it says, if you run out of numbers, you add a decimal and a 0. The last thing we have is talking about how to turn a decimal into a fraction. So the way that we do this is we look at the place value. So you have start with 2.2. Well, that's actually 2 and 2/10. So I would keep my big number of 2, and then I would put 2 over 10. On the next one, you have 2.38, which is the same thing as 2 and 38/100. So I keep my big 2, and then I put 38 over 100. And then the last one, I have 2 and 573 thousandths. So I put 573 over 1,000. Now, of course, you'll probably have to simplify this, like 2/10 can be simplified down to 1/5 and so on and so forth, but that's how you do it. You just put it over the place value. That's it. So this is the decimal one. So adding and subtracting, line up your decimals. You can pause here if you need it. Multiplying, you go through and you multiply your decimals. You can pause here if you need to. Then here's your division, and you can pause here if you need to. And then here is your turning it into a fraction. All right, the next one that we have is adding integers, subtracting integers, multiplying and dividing integers, and then if you have two negatives next to each other. So when adding and subtracting, if you have same signs, you add. If you have different signs, you subtract, and we always keep the sign of the bigger number. So if we look at this first example right here, I have -3 plus 7. Those are different signs, and different signs subtract. So 7 minus 3 is 4. And then I keep the sign of the bigger number. The bigger number is 7, so I have a positive 4. The next one, you have two negatives. Same signs, add. 3 plus 7 is 10, and then you keep the sign of the bigger number. The bigger number here is 7, so it's a negative. The next one, we have two different signs, and so I subtract, and then I keep the sign of the bigger number. The bigger number is 7, so I have -4. And then on the last one, you have two positives, and so you add, and you keep the sign of the bigger number, and so it is a positive 10. The next thing is if you are subtracting. Same signs add, different signs subtract, and you always keep the sign of the bigger number. A subtraction symbol is the same thing as a negative. So when I take a look at my first example right here, this is -3 and -7. Those are same signs. Same signs add. 3 plus 7 is 10. And then I keep the sign of the bigger number. 7 is negative, so 10 is negative. Right here, I have a +3 and I have a -7. Different signs subtract. So I do 3 minus 7, which is 4, and I keep the sign of the bigger number. 7 is a negative because subtraction is a negative. And then for the last one, I have 7 minus 3. Those are different signs because 3 is negative, 7 is positive, so I subtract and I keep the sign of the bigger number. 7 is bigger, so that is a +4. When you are multiplying and dividing, if you have the same signs, it's positive, different signs is negative. So for instance, a positive times a positive is a positive. A negative times a negative is a positive. A positive times a negative is a negative. So this first example, I have a positive times a positive, which is a positive. That's same signs. 8 times 4 is 32. On the next one, I have same signs, a -8 times a -4. Same signs give me a positive, so that is 32. A negative times a negative is a positive. On the next one, I have a negative times a positive, and a negative times a positive is a negative. On the last one, I have a negative times a positive, and a negative times a positive is a negative. And on the last one, it's talking about if you have two negative symbols that are directly next to each other. So right here, you have two negative symbols that are like right next to each other. And two negatives that are right next to each other become a positive. So this turns from 5 minus -8 to 5 plus 7, which is 12. And this one turns from -5 minus -7 to -5 plus 7, This is different signs subtract. So 7 minus 5 is 2. And I keep the sign of the bigger number, so it's a negative. I'm going to go back through just in case you need some stuff. Same signs add, different signs subtract. Whole thing right here, okay? Then here's your subtraction tab. Here's your multiplication and division tab. And then here's your two negatives right next to each other tab. The next thing that we have is equations. So we're talking about inverses here. The inverse of a positive is a negative. The inverse of a negative is a positive. The inverse of multiplication is division, and the inverse of division is multiplication. The next one right here is just your steps, and there's nothing to write on this one because we've talked about this so many times. You draw a line through the equal sign, circle the coefficient and the variable, or shield it, and then you get rid of addition with subtraction, you get rid of multiplication with division. Then this one right here, there's also nothing to put. It's just when you flip your inequality sign. So you flip your inequality sign if your coefficient is negative, which means if the number inside your shield is negative, or you can flip it if x or the variable on the right is, if x or the variable is on the right side. And if you have both of those happening, then you would flip it twice. This right here is just your graphing. So if it doesn't have a line under it, it's open. So these are both open because it doesn't have a line. So I put an open around my 2's. Then I just make a little arrow, and that will tell me the direction it goes. And I can only do that if x is on the left side. It's all numbers that x is greater than 2, so it goes that way. This one is all numbers that x is less than 2, so it goes this way. Now this one has a line underneath it, so it's closed. So we put a closed dot here, and then this points to the left direction, and so I have this go to the left. This one has a line underneath it, so it's a closed dot. And then it's all numbers that go to the left because it's less than 2. And then this last thing that we're talking about is if your coefficient has a fraction. And if your coefficient has a fraction, what you need to do is you have to multiply by the flip. So I do all of my steps like I normally do. I drew the line through the equal sign, I did the shield, and then I subtracted 3 from both sides. And I ended up with 1/4 x is equal to -9. So to get rid of that fraction, instead of turning it into a decimal, all you have to do is multiply by the flip. And the flip of 1/4 is 4/1. 4/1 is the same thing as 4. And so all you have to do is just multiply -9 times 4, which gives me -36. And then the last thing that we have right here is just talking about if you're given an equation, like if you're given a word problem and ask you to write an equation, if you have a total that goes into y, if you have a multiple that goes into m, and if you have a 1/starting value that goes into b. So I'm going to go through this one more time. Here's your inverse operations. Steps are already there. Flipping an equality sign is already there. Here is which direction to graph. And then right here is how to get rid of a fraction coefficient. And then this right here is your vocabulary. The last foldable that you're going to go through is your proportions foldable. So you have word ratios, part whole, percent of change, and unit rate. So if we look at this first example right here, it is Diana went to the grocery store, 3 bananas cost $2. How much would 6 bananas cost? So we don't see a percent, which means I should not be using a percent proportion. It says the same unit twice. It says bananas, and it says cost. When you see the same unit twice, that is a proportion every time. So your first step is to do your 3 lines. And in my first line is my word proportion, or my word ratio. So I have bananas, and I have cost. The next step is to set up my numbers. What's in the first sentence goes in the first ratio. So it says 3 bananas cost $2. So 3 bananas cost $2. Then it says how much would 6 bananas cost in the second sentence. So that goes in my second ratio. 6 bananas goes across from bananas. And then I don't know what the cost is, so I put an X right there. And then after that, you cross multiply and you solve it. So you have 3 times x, which is 3x. And then you have 2 times 6, which is 12. After that, we divide both sides by 3. And you find out that 6 bananas will cost $4. Then right here, you have 12% of flowers are daisies. If there are 300 flowers at a flower shop, how many are daisies? So this time it says percent, which means we're either using a part whole or a percent of change. We ask ourselves, did anything change? No, the number of flowers did not increase. So I'm using a part whole. So I set it up in the form of part whole. 12% goes in the percent spot, which is always above 100. Then I just have to look at my other number and see if that's a part of a whole. So it says if there are 300 flowers at a flower shop, that's a total. Totals go with the whole. So that means my whole is going to have 300, and then x is going to go in the part, and then you just cross multiply and solve. This one right here is percent of change. Because a sweater went from $15 to $20, what is the percent increase? So it says the word percent and something changed. Now, the big thing to remember with percent of change is that to calculate the change, you have to subtract. So your change would be your prices subtracted. Your old is going to be the original cost or however much was originally there. So the sweater used to be $15, so that's the old cost. And then you have percent over 100. And then instead of that percent, I'm going to put x. The last thing that we're going to talk about is unit rate. We know that this is unit rate because it says per. Or if it ever asks for a unit rate, that just means to divide. So we're going to divide $4.50 because cost always goes on the inside by 3. And that's it. So this is your proportions and how to do it. So this right here is your word ratio. This right here is your part whole. This right here is your percent of change. And this right here is your division. Okay, so please put these into your binder and do not lose them. We're going to come back to this on the Monday after break. Please do not lose this.